Excellent. I'd now like to invite Michael Yingbull, who's one of our professors at Conestoga College and one of our faculty engaged in research with the SMART Centre, has been for, I don't know, long before I got here anyway, Michael. And we'll come up and talk to everyone about open source versus cloud tools.
All right, well, I'll start talking as we're already a few minutes behind, and professors are not usually good at fixing that, but I'll see what I can do. As a lot of what I want to do is share a bit about what we've been up to with one of our projects and get a chance for us all to talk, because I think many of you came here with questions or looking for new ones. And while I can't necessarily give you all the answers, I see a big part of what I do is trying to dig onto the unknown unknowns and hopefully can give you some new ideas of things to be inquisitive about. So a big part of what I'm here to talk about is some of the work we've been doing around AI at the edge, particularly around how we're using local tools, largely put together with open source models, to be able to implement AI right where we are. That can be anything from on some gaming PC that someone picked up off the store, to laptops and hardware that's getting much better at being able to run these types of workloads. I think of the Macs as well as some of what's coming out with Microsoft, where we have high memory bandwidth capability, as well as what we're seeing happening where we're trying to embed AI where it's happening. And that's where we're seeing work being done around devices that we can have in drones, robotics, or at least near them. So not everything needs to go to the cloud when we're talking about making use of AI. So a little bit of what got us here. So current project that I've been working on started with a doctor going back, it sort of started around the end of 2023. And that doctor was really not having much work to do. No, that doctor had a lot of work to do. And it was a lot of work that was administrative and writing notes and making things pretty. And it was work that they've proven can be really helpful if you have someone else writing some of the notes. I had doctors tell me, yeah, I wish I could just go in one room, look after my patients, move on to the next one. And doctors are really desperate. And I think our healthcare system is really desperate for tools that can help with the workload that the doctors are doing that isn't just applying their uniqueness of what they bring as a practitioner. So that was around the time we started to see a lot of the commercial tools coming out to say, hey, we can record what's going on, and we can, give you transcripts, and we can write notes for you. It'll be great. And the doctor in question that I led to this research project was like, well, that's great, but what's happening with the data? And then it was a bit quiet. And then it was like, well, how is it being processed? And then it's like, well, that's my IP. And the doctor was like, but I want this. And so I was talking with him, and we shot a few emails back and forth, and we showed pretty quickly. At that time, we were using a open source model from a company named Demystifying that had been released fairly recently. And we proved that, hey, if we have a transcript of kind of even just the flow of text coming out of a meeting with a patient and doctor, we can create a note right here on our computer. And at that point, we're using about a $300 video card to do it. So hence became the project to look at how we can build something that is open source so that how these tools work is transparent to the practitioners, using open source tools for artificial intelligence. I'm not gonna wave too much here because I know some of this has already been talked about, but I think I'll probably get believers if the idea around privacy and IP control is a concern, especially with anything, let alone AI, but anytime we're using any cloud service. If nothing else, there are focused targets for attack, and we can go back on the news to see various cloud providers that have had leaks in many different tools and industries. So we've been trying to get more transparency in here. Various laws around disclosures. But this was one of the other ones that came up with the doc, is he kind of said, well, here's the problem. I'm required to get informed consent from these patients about what I'm doing with their healthcare information, their data. I don't really know what's going on. Besides, it's going to this company and they're promising me they're doing good things and it should be fine. But there's only so much that I know. So that again pushed the idea that by building the solution, using the open source tools that exist, using models that can be chosen and changed and are defined, we can look to address that. Sound interesting so far? There's a lot that can be done. I'll talk a little bit about the cons as well, but to me, it goes back to those unknown unknowns. If I know that I'm working with a model that might have potential issues, that might have data sets that maybe I don't fully know or I want to check, I can work with that. We can look to mitigate and manage things that we know. Again, I'm going to go over fairly quick because I can explain more in questions and discussion, which I'd love to get to. But for this discussion, I'm talking about Edge AI being anything that's happening kind of where we are as an organization. So that would be things that are on our own devices in our organization or within our organization's network. So we can be having servers, everything from that gaming machine we picked up off of Amazon to Jetson NVIDIA devices to cloud computing that we have reserved and rented specifically for our use to run these. By open source, I'm referring to software that's been released under a license that has permissive use and ability to change it. It is worth noting, not all these models and tools you can get use the same type of license, and it is worth looking at the license. Most commonly though, if you see the Apache license or the MIT licenses, these are the most permissive and also the most common that we're seeing in use. That allows them to pretty much do anything with a few caveats around seeing that license continues if you share it. As a very big summary, it can be used for commercial purposes. You don't have to share it, that sort of thing. Again, the transparency helps a lot, and it's different from where we've been because we've been moving more and more away from that idea of security through obscurity, but I really feel that matters quite a bit when we're dealing with AI because we can only mitigate and get consent on things that are defined. Many of the core tools that are being used by these commercial companies to build these products, while there's software and code that may be proprietary, I'm sure there's plenty of proprietary code going on over at OpenAI, a lot of the tools that are being built here are being built out in the open to work with them. So we're building on kind of what is already the foundation of technology in this area. All right, so it's not all roses. I like it to be perfect, but what I will say is that many of the issues we still have to manage when we're working on the edge are a lot of the issues we still have interfacing with quote-unquote cloud. The difference is, while we may have to engage or maybe even potentially look at using other providers or tools to help us, we have that visibility of what we are doing and can metric and test and verify our compliance with our goals. So we still have to worry about bias. So that is where these models were trained. There's been a lot of talk about some really interesting models that have come out of, for example, China, that are seeing a lot of use. We have DeepSeek, we have the Quen models that Alibaba's put forward. So these are very interesting, highly scientific models. But be it today or down the road, it's still a matter of what is that data, what are the biases of that data, and could there be potential exploitations put together around answers. There's been papers that have proven it's possible to train models such that given particular prompts or say input that is indicating a date is past a certain date, that they could quote unquote go evil and start to give different results. So we have to look at what we are using, how they are tested, and what we can know about how they are built. The good news is we have lots of organizations that I feel we can look at as at least potentially trustworthy to a point of what they are giving us in terms of not necessarily putting in direct issues, but we can also now build our own pipelines around that to potentially then verify or quality control inputs and outputs. So what did we do? So we got a grant approved. Conestoga had a program in place to fund applied research projects quite generously through our Synergy Plus applied research grant program. And we were funded starting in the fall, last fall in 2024, for doing this work. And we are currently in our final phase. And what we set out to do was to create a tool that, with no reliance on the internet, could do transcription and translation of healthcare provider and patient conversations with AI note generation and ambient assistance. Not too hard, right? The thing is that the pieces are there for a lot of these things we want to do. And where the fun or the magic happens is looking at how we can put them together. And that's a lot of the value add of cloud providers in general. We've seen that for a long time with various software tools, is that the value add is that they're taking all the work to put it together for us. So we set about to do it. And it even works. We currently have a release candidate up on our GitHub. We're fine-tuning right now how we are processing with the LMM on the output, but it's doing some really interesting things for us. And we really enjoy the close collaboration we have with our stakeholders that are working physicians and specialists. So what we settled on right now is we're using fairly small models to handle the LMM-related tasks. So at the moment, we're making use of the Gemma 2, Gemma 3 from Google models. I'm looking at moving a bit more to some of the models that have a bit more definitive training data that we can point to say, hey, this is what was fed in to make it. There are some that are pushing that. Granite at IBM does a bit, and there's some other more academic ones I'm curious about, particularly with some fine-tuning that might fit. And the other piece we have is we've made the models that OpenAI released with Whisper, which is their voice-to-text tool, work for the transcription and translation. And I am actually saying translation. What we have confirmed with a couple of our partners is we've had this work where we have a patient and doctor who are, in the case of one of them, this is in a Francophone area, and the conversation actually flips back and forth between English and French, just because of familiarity with the rules and just sort of cultural use. And it's able to work with that. Using some fairly basic processes right now, we've been able to have it be quite good at picking up common medical context, because we can adjust how we are prompting some of these tools. So for example, we can teach it, the word CPAP is a used acronym for a breathing device without, say, having to do like training or the like to it. It does take a little more resources when we ask it to do the translation, but it's impressive what can happen, and this is entirely doable, for example, on Mac Mini hardware with the modern ones, or the laptops. One of our biggest things as well was to really focus on what we can do with CPU only. And I want to highlight that because it's important to not get the mindset that because you don't have something with a stamp on the side that says NVIDIA, that you can't make it do AI workloads. The larger the data set is where we'll run into challenges. Training is harder. Building some of these models is harder without the math horsepower we have on some of those chips. But running them largely depends on access to memory. You need a bit of CPU, but access to memory. It scales up the larger the models are. But for example, there's use cases of having these smaller 1 to 4B models, even getting to 7 or 8, working on Raspberry Pi or Orange Pi type hardware. There's also the Jetson Nano, Jetson boards that can put 16 gigs worth of NVIDIA grade GPU onto a mobile chip that you could put into a robot, a drone, and runs on about 25 watts. So it's important to recognize that CPU can do a lot, particularly if our models are not huge that we need, and we can do a lot with these smaller models. So this again, one of the things that is key for this in the context of our physicians is this is now making their consent process really clear. They can tell their patients. Because have anyone been to a doctor's office that's been using one of these scribe tools? A few? I'm not sure what your, was there a big conversation about it when you started? Okay. Yeah. Yeah. Does any of the data go to the US or not go to the US? Do you know? Yeah, and it's hard. It's sometimes hard for them to specify because it's not always clear. Whereas with this, he can say, hey, I'm doing this work here, and all this will stay on my laptop. So nothing's being sent out of here. And the people are like, oh, that's cool. Okay. Because again, is your voice being sent? Is it just a transcript? All these things, again, it makes it hard to really get informed consent with the current models that are being used. We've also got a prototype. We built this one in Python standalone, so it could work with really anything. We've also got a web-based plugin, because what you can also build when we talk about the edge is you can build applications that go down to an end user just using as a plugin or a web app, and it can tap into the ability to run these types of workloads on their own hardware. So this whole process will work without the internet. We don't need the internet for them to be able to use this. We're still, of course, working to keep improving it, to find the use cases where the doctors can find ways to break it or want to get a better transcript quality, but it works. I probably should have thrown the URL up. I can maybe get that passed along at some point for our GitHub site. But we do have all the code that we've been working on GitHub, as well as the developer community we have there. We've also had some interesting work, again, with fine-tuning, because we were hopefully able to and are showing promise in getting better results out of the smaller models. We had some early work, and we're building some testing pipelines for it right now, of just even using the 1B token model of Gemma 3. All right, so that's, I guess, the unknowns of doors opening I wanted to talk about, of what's possible. And you probably have questions, or maybe want to talk about things that you are doing or interested in. So I like to talk, so I want to get a chance to hear from all of you. So what are your thoughts? Have it given anyone at least an idea of something? Yeah.
Artificial intelligence has obviously been identified as a pretty big disruptor in a lot of industries.
Yes.
People are now trying to use it for business development purposes. One of the biggest concerns is that where the data is going, the proprietary information that's being provided to these models.
That's right.
Do you feel that this is the future of AI implementation being run on local hardware as opposed to cloud data?
Absolutely. I really feel that more and more, if the workload does not require the immensity of remote data centers, or hasn't been turned into something super special, right? That is just so good and put this way that we just don't care. For example, I put that kind of like how Shopify has sort of taken over a lot of the e-commerce, right? But short of something that's just so special with special sauce, and we're just going to put it there, absolutely. More and more is going to come down to the edge, because the edge can do it. Our devices can run these tools. We will still need larger models. They can be used for creating data sets, helping us with training some of these tools. But for example, there's another great open source tool that I recommend, especially when working with data, called Anything LMM. And with something like that, you could point it at any of these open source models. You might want a slightly larger one, but these are still things that can run on consumer grade hardware. And it can look at a stack of documents that you have. This is a built-in tool. You don't need to do a lot of coding to make it work. You can point it at your documents, and you can ask it questions about them. You can build things from it. You can build agent-like tooling into it to say, hey, you can go and ask this server internally for this. And that's, again, one of the things that I think is critical about this space, is that there's a lot more we can do with the ambient assistance that we're aiming for, but that's going to involve talking to the electronic medical record system. And I'm not interested in OpenAI connecting on an API level to ask anything it wants when it thinks it needs it from the EMR. That doesn't, I don't like that. The doctors don't like that. I'm open to be convinced, but I don't think that's a great idea. So when we have the sensitive data, or proprietary data, by having it processed locally, which again, we're seeing, we currently, immense power out of these 16 to 32 B parameter models that will run happily on a slightly up Mac, but nothing that's, I'd say, a mega computer, as well as just hardware that you can buy at reasonable prices that you can put in your own servers, your own desktops, your own workstations. Do you have a?
To follow up on that, do you feel that this will change the data privacy industry as a whole? Like, with people's concerns with AI gathering information and being used to train models further, is this something that's going to change people's mind on, in general, providing companies large quantities of data?
I think it will. I think it will, because I think it's going to keep getting talked about. And I think people will see how it's relevant to them, because it's going to be the same type of problem. Whether I'm talking about educational data of me as a student, medical data as me as a human being, my financial data, all of these things will start to say, hey, it's going there. And this has already been a concern in places with cloud services to begin with, and the focus on data that we're seeing there, even when it is de-aggregated, or put there so that it's just all together. But yeah, I believe it's going to push it further. We've seen that with the legislation that's been starting to come through at provincial and attempted at national levels. But I think it's got that visibility and people can see what it's capable of, right?
Probably a long haul, but with quantum computing coming out,
Yep.
how do you see training these models?
So it's interesting. The key thing is looking at, I think, how the algorithms that get done as far as building these things adapt to quantum. We still need to have really wide memory spaces in whatever we're using for this, particularly when we're doing inference. I can't say I've got a hard opinion on it right now, but I will say we're seeing the innovation isn't stopping in how this works. Microsoft put out a model fairly recently that they called BitNet, that was based around just zeros and ones and showing the power of that. Now, how does that work when we can express or have things in more states with quantum in terms of modeling some of this at the base level? I think that could be really interesting. Quantum computing is still sort of stabilizing as a genre, and it still has, I think, multiple instances thereof of how it is implemented. But yeah, I don't think I'm in a place I could make too much of a prediction on it. But what I will say is the innovation pipeline for what we're seeing in AI, like we talk about or remember old Moore's Law, and it's just accelerating every time to the tune that the tools we have when we started the project are stronger or now than when we started 8 months ago. Any other questions? If you were also wanting to write down something else to really see what's there in the open, there's a website known as Hugging Face. I know for many of you, if you have not met it before, if someone sent you a link to Hugging Face, you may not click that link, and your IT security people would be proud of you. But Hugging Face is I guess you could say, a clearinghouse of open data sets for building AI, as well as a place for storing models and quantizations of those models for use. So again, if I can ignite some thoughts and queries, looking at those sorts of sites, looking at their leaderboards, there's many leaderboards that show things for particular tasks. I guess the last cool thing I will share with you for ideas that could be a talk on its own is one of the tools that helped enable us to build this itself was a local AI coding tool called Aider. So we have not used that to point to local AI models yet, but from what I'm seeing, I think we almost could. What that meant is we now had a Python-based text tool that we could use as a paired programmer talking to OpenAI, Anthropic, but we were in control of what files from our repo we were sending to it. Now for us, since this was open source, we weren't overly concerned beyond some intricacies of licenses, but it meant we had that visibility again of how we were using these tools. So happy to chat more. I think we're looking to close up with our time.
Yeah.
So
You'll be around.
I think I'm fairly easy to spot, and I'm happy to chat over lunch or anything as the day goes on. Thank you so much.
Thank you, Michael. That was awesome.